YouTube also. That day you saw all this video on the YouTube. Video or did you not?
Yes, sir.
Yes, sir. Yes, sir.
Fine. So I'm starting up the topic factors affecting the deviation through a prism. Deviation through the prism. How are we going to do it and what is that all about? So there are various factors. There are various factors which affect the deviation through the prism. Let us see what they are. So first one I discussed that day, that deviation is depending upon the angle of incidence. I once again take this point a little bit with you all. So that day I show you a prism. Now, what does prism do? It basically it always deviates light ray from normal like this, and this is the deviation cost. All right, you understand that? All of you remember this?
Yes, sir.
All
Yes, sir.
fine. We had proved this that day. So no point of repeating it. Everybody was there that day. Okay. So now try to understand this further. This was angle of incidence at the first surface, and angle of emergence, refraction at first surface, incidence at second surface, and so on and so forth. We've done this before. So the point says that initially when angle of incidence is increased, now you should write down in short in your book, is increase delta, decrease initially, delta increase decrease initially, reaches its lowest point, and then when further angle I is increased, delta also starts showing the increase in its value. There was a I delta curve. I show you that day. It's a U curve, also called as. Now U curve is basically shows that. I'm making a diagram for you.
जो हमने सेकंड लिंक भेजा उससे कनेक्ट हो. अच्छा, नेट प्रॉब्लम और इधर सारी वीडियो YouTube पे कर रहे हैं वो, ठीक है.
So this is I, this is delta. Delta is increasing. This value is the minimum value, delta minimum. Now, who will tell me what happens at delta minimum? What are the properties which prism shows and the light ray shows when delta is minimum? Delta minimum means.
Sir.
The question. when
Emergence.
the angle of deviation is minimum. What is that point?
So the angle of incidence
The angle of
becomes equal to the
to
angle
the
of
angle of
Angle of
emergence.
emergence.
Equal to angle
the
of
refracted ray is
Incidence is
parallel to
parallel to
the
the base of the
base
prism.
Understand?
BC.
Ri equals to R2.
I equal to E. I equal to E. Refracted ray travels parallel. The base of the prism, right? So this light is traveling parallel to the base of the prism. Understand? It happens only when
Yes, sir.
it happens only when triangle is equilateral
And R1 is equal to R2 and R is equal to R2.
and delta is minimum. These conditions are required. These conditions are required for light to travel parallel to the base of the prism. Understand?
Yes, sir. Yes, sir. Yes,
Right.
sir.
Right. So the next point. So the next point. So now this was all about that angle of incidence, and we had proved a formula. We had proved a formula for these two things. The formula was, बोलिए, I plus E
I is equals to S plus A upon
I
E.
plus C equals to
A
A
plus
plus
delta.
I equals
I
to
is
I
E
I
plus
plus
delta.
E
plus delta.
quite I plus E equals to A plus delta. Now since I and E are equal, I can write down E plus, I
2I.
can write down 2I equal to A plus delta,
plus
or
delta.
delta equals to
A minus 2I.
2y minus
A
A.
minus 2I.
right. That is what we can write down. My angle is opposite.
Yes, sir.
Right?
Yes, sir. Yes, sir.
Yes, sir.
That is 2I minus A. Okay. Okay. That is all happening when the light is suffering minimum deviation through a prism. That also means, if I make a diagram once again for you, a little bit more, because this is the most important point of all these points with us. If I make a point again, and I make a curve for you. So this point is I, a specific value, and for that delta is minimum. So as you end, if you are, suppose the I is value of I is, say, suppose 45 degree. So if value of I is less than 45, delta is more, right? Value I is more than 45, delta is again more. Delta is again increasing. ये जो point है, ये curve का is a minima of the curve. It is the minimum of the curve, minimum most value of this I delta curve. Curve का turning point, curve का upward turning point है, right? किसी भी curve में किसी एक specific value पर केवल एक unique turning point हो सकता है. It can't have more than one turning point at that point. And so this value this value is the unique value for every one angle of incidence. There is a unique characteristic value of delta minimum. It will not be more or less than that. It's a uniqueness is there. Because if I draw a tangent, if I draw a tangent at this point, if I draw a tangent at this point, I can't draw the another tangent at this point. It can be a one tangent only at this point, isn't it? Is that fine with you all? So
Yes, sir.
किसी भी
Yes, sir.
किसी भी एक एंगल ऑफ इंसिडेंस पर यूनिक डेल्टा होता है. डेल्टा की वैल्यू यूनिक होती है एट दैट पॉइंट. इज दैट क्लियर?
Yes, sir.
चलिए
Yes,
fine. So I am moving
Yes,
from
sir.
here. I am moving up from here. I think there are some questions given to us in the book. I will take them later on. That is simply a relation between the two delta to I equals to A plus delta, and there's some questions on that. We got to find the values of minimum deviation and all on those questions. We can take it later on, no problem in that. Let us first of all cover up this remaining 3 points. Okay, so the next point is dependence of angle of deviation on the material of the prism. Dependence of angle of deviation on the material of the prism. Material of the prism. Yeah. So what is this material of prism? Material of prism. Material of prism, basically, what does the material do here in this process on the whole? Tell me. What is the purpose of what is the purpose of that material of prism? Material of prism provides a denser medium for for light to be refracted. Material का purpose क्या है? Light को refract करना. So the prism is trying to refract light more and more. So if the material has got more refractive index, if the material has got more refractive index, then it will of course deviate light more, isn't it? So if there are two prisms, suppose consider kariye, and one of them has got a higher refractive index, another got the lower refractive index, it is found that for a given angle of incidence, the prism with a higher refractive index produces greater deviation than the prism which has a lower refractive index, and that is why that means those material with high refractive index will provide more deviation than those prisms having material of low refractive index. Understand? So let us see here. They're giving example of the crown glass prism and a flint glass prism. So understand this point carefully. Suppose you have two prisms here. The first prism and the second prism. This is, say, the flint glass, and this is, say, the crown glass. the mu, the refractive index of flint glass is more than the refractive index of crown glass. Okay. So when this happens, that the Ri of mu, Ri of the material medium is more, then for the given angle of incidence I, for given angle of incidence I, delta is more for flint than delta for crown glass. So it depends upon what kind of material we are using in the prisms and how much it depends upon what kind of, you know, what kind of material we are using for deviation in the prism. It has got higher refractive index, of course it will provide more deviation, so light will deviate more, and जो incidence होगा वो ज़्यादा हो जाएगा, and crown glass का जो deviation होगा वो कम होगा. ये value और ये values में फर्क आ जाएगा. It depends upon the material of the glass prism or that refracting medium and how much refraction it is providing. So a flint glass prism produces more than, if I sum up this, basically what happens is that the material mediums provide different refractive index for different mediums. The material medium provides different refractive index for different, different light rays. So what happens is that, suppose I'm the light of say red color. The second point, So the first one was the material of the prism. The second point is, and the more important, the lambda of the incident light. I'm making a next diagram for you. The next point I'm taking up, and that point is wavelength or frequency of incident ray. Wavelength or frequency of incident ray. Let us understand the point. And this is a very important point, बच्चों, because इस पे बहुत सारे questions हमको मिल जाते हैं exams में. तो प्लीज जरा इसको ध्यान से सब बना के रखिएगा. चलिए, I make it here like this. I change the color for the incident light. Suppose, fine. All right. Say this is the bullet color, blue color, and take red color. Let me make the angle of incidence same for red color also, almost same. Imagine करिए कि दोनों same color की light, दोनों same angle of incidence per incidence, right? Imagine this way. Now what will happen that जो light red color की है वो इतनी ज़्यादा deviate नहीं होती है. And it falls above the violet light somewhere on the spectrum. Why this is happening? इन दोनों light rays में क्या difference है? ये violet है और ये red है. We have discussed this before also. Now I'm telling you, please don't interrupt in between anyone. So what is happening here is that these light rays are traveling at the same speed in air, because यहाँ पर ये homogeneous medium है. This homogeneous medium keep the light rays at the same speed. We don't see different light in air. We see only white light in air. Why only white light in air? Because all the lights are traveling at same speed in air. So they might be a higher wavelength or lesser wavelength, or higher frequency or lesser frequency. It does not make any difference. Ultimately, they are all traveling at same speed in the air. And so they're not separating their path. They're traveling club with each other. All the 7 basic spectral colors make white light. We find white light around us in air. As soon as they enter glass, as soon as they enter glass medium. Now, glass medium, the second medium, glass medium always separates these light rays, spectral colors. How it separates them? Because they have got different wavelength. This different wavelength provides different velocities to these light rays, spectral colors inside the prism. So each spectral color travels at its own individual velocity inside the prism. Note it down. Note down in the sideway in your book somewhere. Hello. Yeah, let us continue. So I got so the two all the 7 colors of this white light. Say here is white light. So I got multiple colors traveling, all reaching the prism at the same angle of incidence. But as soon as they enter the prism, now each spectral color that means different wavelength. Different wavelength means different frequency, right? जैसे ही ये ग्लास में एंटर करते हैं, ग्लास take them separately. Glass consider them as 7 different colors, or all the waves, different waves coming to itself, and it provides the different velocities. To them. Now, different velocity means different deviation. Different deviation. Light is deviated at separate angle of deviations. Delta, red, delta, violet. Fine. Now, out of these deviations, delta red is the least and delta violet is the maximum for a given prism at a given angle of incidence. So from top to bottom in the prism, the value of delta keep on increasing. And that is why in the spectrum, violet color is always at the lowest. It is always at the lowest, and red is always at the highest position. you take any source of light, you take any refracting medium, be it prism, be it whatever. Whenever a refraction is happening of a white light, it will always be like this. It will always be like all these colors are distributed, they are dispersed. This is called as dispersion also. This phenomena is called dispersion of white light through the prism. It's not scattering. Remember this. I'm writing a word here. This word is called as dispersion. Light is suffering dispersion while traveling from air to prism, being separated out in all its 7 constituents color. All its 7 constituents color at different angle of deviations, depending upon that which light is of longer wavelength and which light is of shorter wavelength. Longer the wavelength, lesser is the deviation. Write down in your copy in your book somewhere these points properly. Longer the wavelength, lesser the deviation, or you can say lesser angle of deviation. Delta is less for longer. For longer wavelength, or lesser frequency. Understand? I hope you understand all.
Yes, sir.
Yes, sir.
Yes, sir.
The shorter wavelength, the shorter wavelength, say shorter wavelength, more deviation. More deviation. What else?
More the frequency.
More frequency.
Greater angle of deviation. Greater delta, I mean. Fine. Greater delta. And you can say more shorter wavelength or higher frequency. So from moving from top to bottom in a spectrum, top to bottom in a spectrum, what will happen? Tell me, what will happen? Wavelength decreases. Second बोलिए.
Frequency increases.
Frequency increases.
Delta
Deviation
increases.
increases.
Understand everyone?
Yes, sir. Sir.
Right?
Yes, sir.
Okay.
Yes, sir.
Then one more point is there, angle of deviation of the, it depends upon the angle of prism also. More the angle of prism, more is the angle of deviation. More the angle of prism, more is the angle of deviation. So we've got these kinds of dependencies of a prism. I mean, for a light to be dependent on